Hello, it's Mr. Robs.
And Mrs. Flynn.
What do you have for us today, Mrs. Flynn? I see a triangle and they're one of my favorite shapes.
Oh, and you know what? It might not say this, but in reality, this really is just a right triangle. So maybe that should be drawn right there.
Right. Okay.
So find the length of AB. Oh, the AB. How can we describe that? Like,
Oh, if it's a right triangle, then I call that the hypotenuse,
Yeah,
which is
it's
the
opposite
longest side.
opposite your 90-degree angle. So I know how to solve for that. I can use Pythagorean theorem. So, and we all have used this a little bit. A squared plus B squared equals C squared.
Right. And so C is always the hypotenuse. So that's the AB we're looking for.
And this is A, and this is B. All right, so now we can just substitute in values.
Right.
24 squared plus 5 squared equals C squared.
Okay, now 24 squared.
I don't have that one memorized.
No, I do not.
576.
Every time I see it, I go, oh, okay, I've seen that before.
Yeah.
I have the 5 squared memorized. That's 25.
Oh, you're so smart.
I work hard.
All right. So we can go over here and add it, unless you have that
No.
in your head.
601?
Oh, yeah. 601 equals C squared. And to find the exact value would be the square root of 601.
Right. Sounds good to me. And if we wanted approximate, so if this was like a road length, we want to know like the approximate length of the road.
Well, then we would just do square root. Yikes. And answer. You showed me that one.
Yep. 24.5.
All right.
That's the three significant figures. 24.5 cm.
Yep. Okay. Let's go over here. How do we find the distance between A and B?
Well, we did Pythagorean theorem.
Okay. So if we just dropped a horizontal line here, or vertical.
Right. And the other vertical, which is horizontal.
Makes a 90-degree angle.
All right. And so we did A squared plus B squared is C squared. Well, how are we going to get those lengths for A and B?
Well, the distance of this point here, I know,
right.
goes from A all the way to C. So this distance is just going to be C minus A.
Ooh, okay. And so we can use that same logic on the other side, I guess, then. That bottom line there is all the way up to B. And the top will be D.
Okay.
So the distance then must be D minus B. All right.
Okay, now we want to find this. Let's call it X.
Okay. So if we want to find X squared, we just square our D's and B's and stuff like that.
Let's see if this gets us anywhere.
All right.
Okay, so A squared, I'll just call that the bottom leg here, plus B squared.
All right, plus B squared. It's just D minus B squared.
Equals, instead of C, we have
X
X
squared.
squared.
And so X, then, if I look at that distance, I just find the square root. And that would be, so X will be the square root of all that.
Okay. C minus A squared plus D minus B squared.
Equal to X. So,
what if these points were called A and B? What if they were instead, they were called X1, Y1?
which they often are, like it's like 2, 5 or something like that, which is our X and our Y.
It's 1.
Oh, 1. Okay.
And this is X2, Y2.
All right, so all we would do then is plug in our values into that for C and D as X and Y. And so the formula then,
For the distance
equals, well, C is X2, C is X2.
Yep. Minus our A value, which right here,
is X1.
X1.
Oh, so we're subtracting, we're subtracting the X values.
There. Oh no. I can write a 1. I can. Okay.
All right, squared. You're right. So plus y2, which is d.
Here's d.
Minus b, which is y1. And we square it. And that is our distance.
Okay. Well, we can use that formula now.
All right, great.
Let's try problem.
Let's do, yeah. So the surveyor must determine the distance around a triangle formed by the three towns, town A, B, and C.
Well, I know my distance formula. We just discovered that.
All right.
That's x2 minus x1.
So the difference in the x's.
Squared plus y2 minus y1 squared.
Right. Okay, so let's find the distance. Let's go to A to B.
A to B first? Okay.
Yep.
A to B.
So square root of, well, x2, x1. So which one do you want to call like 0.1 and 0.2?
I like to call A1. This is x1.
Okay.
Y1.
All right, so the other one must be x2, y2.
Okay, so let's start off with x2. That's 6. Would it have mattered if we picked different ones?
No, it shouldn't, because we're going to take it and we're going to square it. So even if, because the only thing that would matter is that one way would be a positive value and one way would be a negative value. If you square either one of them, you get the signs go away. And then y1 is 1, subtract it, squared.
All right, so now I have 5 squared plus 10 squared.
Nice. So 25 plus 100, 120.
Mr. Romps is tired.
Oh yeah, because 125. Square root of that one.
I think we can leave it in exact form, huh?
Okay. Equals square root of 125. All right.
That's the distance from A to B.
Right. And I like how you're keeping this notation so we can keep track of actually which values you're looking at the A to B. That's good.
Thanks.
Let's do another example. Or not, that's fine. We have to keep finishing this one.
Now we got to find BC.
All right. BC.
Let's find the distance there. Oh, I hope I have enough room.
It's not going to work, I don't
I
think.
can write small. I can do it.
Okay, you can do it. So you want to make C x1? And
Okay.
all right, so 16 minus 6. We square all that. Plus.
Start with the same value,
right,
9.
Minus 11
Squared.
Which is then, again, 10 squared. Plus a negative 2 squared.
Oops. There we go. Negative 2. It's important to have that negative in parentheses so we make sure that we don't forget it.
Yep. Plus 4. Because if you just type negative 2 squared in your calculator, as I said it, you get negative 4, which doesn't make any sense. Be very careful. So there we go, root of 104. And finally, the last one, we have AC to find.
All right, so our distance is, let's start with A.
Okay, so it would be 1 minus 16, all squared, plus 1 minus 9, all squared.
All right, so this gives us the square root of 15 squared plus negative 8 squared.
Okay, so 15 squared is 225.
Oh, you have that one memorized.
I'm hoping I'm right. Someone will tell me if I'm wrong, I'm
You're
sure.
right. Plus 64. Okay, we can add these up. That's 9. That is 8. And 8. Right?
Oh, and 2.
Gosh. That's
You're tired. You're tired as well.
289.
289. That might be a perfect square. Maybe not. I don't know. So now, the question's asking us to find the distance of the, what's it asking us to find? Determine the distance around a triangle formed by the three towns. So if we want to answer the actual question, we have to go and add up all those distances.
So we know that this is the square root of 289. We know that this is the square root of 104. And this is the square root of 125.
Okay. So if we go
How many square roots do you live away from the school?
I live approximately 24.7, square root 24.7 away from MIS.
Square root of what?
Of 24.7.
The square root of 24. So you live 5.
Just about 5, yep. Just a little less than 5. In Starnberg.
We don't normally say that.
You don't?
Square root of how far we live. So
yes.
It's probably pretty accurate, if we, pretty appropriate, I guess, if we say that the total distance, instead of leaving it in exact value.
Right. And we should 3 significant figures always, right?
Yeah.
So the total distance is 38.4.
And units.
Units. All right. Good.
Okay, we're done.